done. We started logarithm. Last week we started logarithm and we stopped on how to identify a logarithm. Talked about index and logarithm of a number and all of that. So today we'll be moving to characteristics of numbers. That is the characteristic of any, how should I put it, logarithmic expression you are given. So it says, to determine the characteristic of numbers, express the number in standard form. The index or power of 10 gives the characteristics. Now, characteristic of a number or of a logarithmic expression is, how should I put it now? The number that comes before the decimal point. If, for example, you are given, you're asked to find the logarithm of 3789. I'm just giving an example, 3789. And you have your logarithm to be 3.5785. The characteristics of that logarithm is 3. The number that comes before the decimal point, that is what we refer to as characteristics in logarithm. So to determine the characteristics of numbers, you express the number in standard form. You have to express the number, write it down in standard form. We've treated standard form. So they said the index or the power of 10 gives the characteristic. So for example, we have 2 examples here. We have 2457. Sorry, please. 57. When we write 257 in standard form, we have it as 2.457 times 10 raised to the power of 3. 2.457 times 10 raised to the power of 3. So the power of 3 we already explained, because we moved from behind 7, or should I say after 7, to behind 4. We moved twice. You move 7, 5, 4, and then you move your decimal point to that's before 4. That's why we have times 10 raised to the power 3. So the index 3, that is the power raised to the power of 3. The power of 10, which is 3, is the characteristic in this number. The second example, if we have 0.02457 is equal to 2.457 times 10 raised to the power of 2. 0.02457, when we write this out in standard form, we have it as 2.457 times 10 raised to the power minus 2. Are you talking to me?
No, ma.
Okay. So we have 2.457 times 10 raised to the power minus 2, because the decimal point moved from after the first 0 to 0.2 after 2. So it moved twice, 0 then 2. So that's why we have times -2. So the index in this case is -2. So we have the characteristic of this number to be -2. Do you have any question as regards that?
Why is it -2?
Okay, it is -2 because we are moving forward. Like, how should I put it? You are moving from behind. Look at the first example. We have a positive power, that is 3, because we moved from, 2457 does not have any decimal point, yes, but we can also say it as a decimal point, in the sense that we can have it as 2457.0, which is the same thing as 2457. And when we are writing anything in logarithm form, the decimal point comes after the first significant number. So because we moved backward from 7, to behind 4 or after 2 in the first example, that's why it is positive. But when you are moving forward, I don't know if you understand what I'm trying to say. You have a negative power, a negative index. Do you understand?
No, ma.
You don't understand. Okay. What I'm trying to say is, looking at example 2, 0.02457, the decimal points moved from 0 to 2, right?
Yes,
After
ma.
the first 0 to after 2, looking at what we wrote as our standard form, 2.457, we moved forward. You moved the decimal point forward from after
Okay,
0
ma.
to after 2. Do you get that?
Yes, ma.
It's moved forward. So when you move forward, when you move your decimal point forward, you have 10 raised to power of -2. You have a negative power. But when you are moving backward, look at the first example where we have 2457. We moved from 7 to behind 4. Now, this might be confusing in the sense that you don't see any decimal points here. But when you have a question like this in mathematics, we assume that there's a decimal point after the last digit, because if we include the decimal points, we have 2457.0. 2457.0 is the same thing as 2457. Do you agree?
Yes, ma.
Because that 0 is insignificant, so we can do away with it. So now, let's say we have an invisible decimal point after 7 in the first example. So, and then we moved the decimal point to after 2. You will see that we moved backward. We moved from 7 to 5, then to 4. Then after 2, we put the decimal point. So we move backward. When you move backward, you have a positive power. When you move the decimal point forward, you have a negative power.
Okay.
Do you understand?
Yes, ma. Okay.
That's why most times when you have 0 point whatever, you always have a negative power in standard form because you are moving forward. So when you move forward, you have negative. When you move backward, you have positive. Just like what? Do you understand that?
Yes, ma.
Any other question?
No, ma. Thank you.
Okay. So we move to logarithm of numbers now. That is how to find logarithm of numbers. In this topic, I think I told us 2 classes before this. I don't know if I said it last week, but I think I remember I told us we will be making use of 4-figure table. So I don't know if you are with your 4-figure table. So we'll be making use of 4-figure table.
Let me get it.
You said?
Let's carry it.
Okay.
Okay, ma. I'm with it.
All right. So logarithm of numbers. When we want to find the logarithm of a number. So they said, find the logarithm of these numbers. We are given 3 numbers. The first one, 0.0563. Right? The third one, 7.253. Find the logarithm of this number. Don't forget, we talked about characteristics already. Now, in a logarithm, whenever you are given the logarithm of a number, the digits before the decimal point, like I said earlier, is called the characteristics. The digits after the decimal point is always called Mantissa. Mantissa. So we have the characteristic part, which is the digits before the decimal point. Now, looking at the first example, 0.0563, we said is equal to, that is, the logarithm is bar 2.7503. Bar 2.7503. Sorry. Bar 2.7505. I mean, that bar 2 minus 2. This is minus 2 in the first example. Sorry, I'm not using the chalkboard today, so my explanation will be somehow. You have to follow me. 0.0563, the first example. Do you know where I am? Yeah?
Solution under logarithm.
Yes. Thank you. The first solution, 0.0563 is equal to bar 2. That is, bar 2 means minus 2. But when you are saying it, sorry. Sorry about that. So 0.0563 is equal to minus 2. It is actually minus, but we don't call it minus when we are saying it under logarithm. When we are saying it in a logarithmic expression, we call it bar. So that's why I'm saying bar 2, but it's actually minus. So bar 2.7505. Now the bar 2 is called the characteristic part. That's the characteristic we explained above, that when you write it out in standard form, the index of the standard form, the power of base 10 is the characteristics. Now the points, the digits after the decimal point, which is 7505, is called the Mantissa. That is always the number we check under our logarithm table. Do you get that?
Yes, sir.
So now we are to find the logarithm of this number. As the first one, 0.0563. How did we come about minus 2 or bar 2? When we write out 0.0563 in standard form, we have it as 5.63 times 10 raised to the power of minus 2. Minus 2 because the power moved, sorry, the decimal point moved forward from after the 40 to after 5. It's moved twice, 0, 5, twice. So we have it as minus 2, negative 2. It's moved forward. The decimal point moved forward twice. So we have it as negative 2. So if we have to write 0.0563 in standard form, we have it as 5.63 times 10 raised to the power of minus 2. That minus 2 is the bar 2 we see before the decimal point. Now, how do we come about 7505?
We'll look for 56 under 3 in the four-figure table.
So what do we have?
We have 7505. That is bar 2.7505.
Thank you. So that is how we come about the logarithm of that. Sorry. Three, 7, 8, 9. So the first thing we do is we write 3, 7, 8, 9 out in standard form. When we write 3, 7, 8, 9 in standard form, what do we have?
Ma?
I said when we write 3789 in standard form, what do we have?
3.5785.
Nope. In standard form. 3.5785. That's the logarithm. So I'm asking a question now. I'm trying to explain the second question, how we came about the logarithm of the second question. So I'm asking, when we have and you are asked to write 3789 in standard form, what do you write?
Okay, 3.789 raised to power 3.
Times 10 raised to the power of 3. Thank you. Because we moved backward thrice. The decimal point moved from behind 9 to after 3 or behind 7. So we have it as 3.789 times 10 raised to the power of 3. So from the power 10, we are able to realize characteristic for question 2, which is 3789 is 3. So that's how we come about 3 points. 3 points. Now, how do we come about 5785? We check 37 under 8, difference 9 under our logarithm table. So when you check 37 under 8, what do we have?
37 under
8.
Okay, 5775.
Difference of 9, we had difference, right? We are adding
Okay.
difference.
Difference of 9. Let me see. 5. Difference of 9 is 11. So plus
10.
it.
Is it 11 or 10?
Let me see. Okay, it's 10 now.
10. So we add difference. When we add it, 5775 plus 10 gives us 5775 plus 10 gives us, okay.
5785.
Good. That's how we came about 3.5785. Then the third one, we have 7.253. Now, in this case, we'll see that the characteristic of this logarithm is 0. Why is it 0? Looking at 7.253, you will see that 7.253 is already written in standard form. So we are not changing anything. Do you get it?
Yes.
It is already in standard form. So now, if there's any power that should be written, maybe we write it as power of 0. We write 7.253 times 10 raised to the power of 0, because 10 raised to the power of 0 is 1. You know, anything raised to the power of 0 is 1.
Yes.
So we have it as 7.253 times 10 raised to the power of 0, which is 7.253 times 1, which is 7.253. So our characteristic there is 0. So that's how we came about 0 point. Now, how do we get the logarithm? We check for 72 under 5.
Difference of 3.
Difference 3, yeah. So when we check 72 under 5, what do we have?
72 under 5 is 8597. 597. Then
72
3.
under 5
Yes, ma'am.
is what?
I'm coming, please. Difference of 3 is 8598.
Oh, that's wrong. Oh. 72 under 5. Please check again.
Okay, ma'am. Difference of what?
72 under 5 is what?
Okay, my 8510.
No, that's not 8510. Are you sure you are checking 72 on that part? On that 5 is
Okay.
can you see my screen?
No. Okay, it's 8605.
Good. Okay. Difference 3.
My difference 3 is the 2. If we plus it to give us 8605.
Thank you. So that's how we came up about 0.8605. They said, note, the logarithm is the decimal part. The logarithm is the decimal part. That is the numbers you have or the digits you have after the decimal point. Why the characteristic is the integral part. Integral means whole. The whole number. Or should we say the whole number? The digits, let's just say the digits before decimal point. That's the characteristic. While the logarithm or the Mantissa is the decimal part. The digits after the decimal point. Do you understand that?
Yes, ma'am.
Now we move to check for anti-logarithm. They said find the anti-logarithm of these numbers. The first one is 0.3416. The second one is, there's a mistake there. It is bar 2. I made a mistake there. Bar 2.3321, that is minus 2.3321. The third one is 1.233. Now we have to find the anti-logarithm.
Okay.
The first one, which is 0.3416. Now the first thing, we said the answer is 2.196. Explaining how we came about 2.196. We said note, you find, the first thing to do is you find the anti-logarithm using anti-logarithm table. That is, you find the anti-logarithm of the integral of the decimal part, Find the anti-logarithm of the numbers after the decimal point. Now, when you are dealing with anti-logarithm, you know that in logarithm, let's come back to logarithm. Whether it is before or after the decimal point, we put it together with it. For instance, we have 7.253. We will say
Yes,
72 under 5 difference 3, right?
yes, ma'am.
We don't neglect the numbers before the decimal point. But note that in anti-logarithm, the numbers before the decimal point have nothing to do with your anti-logarithm table. So if you are checking for any number under the anti-logarithm table, it is the number after the decimal point. That is your decimal part. Do you get it?
Yes, ma'am.
So in this case now, we are asked to find the logarithm of the antilog of 0.3416. So what are we checking under the anti-logarithm table?
34 under 1 difference of 6.
Thank you. So we are checking for 34 under 1 difference of 6 under our anti-logarithm table, which gives us what?
2198. 2188. Then the difference of 6 is, I'm coming. Is 21811.
218 21 think I made a mistake
Now,
there.
come here.
Okay. 34 under 1 is what?
Ma 219. 219. Okay, the only before the difference.
Yes.
218.
No.
8.
That should be 2193. You are checking 34 under 2.
Sorry, 2193. 2193.
When you add the difference.
Okay, 2196.
2196. So you can see that it said note 1. Find the antilog using antilogarithm table. You check 34 under 1 difference 6. You add the difference. That is, we have 2193 plus 3, which gives us 2196, right?
Yes, ma'am.
Now, after getting our antilog, using the antilogarithm table, which in this case is 2196, the next thing to do is you fix the decimal point position. This is where our characteristic, that is the number before the decimal points, come into play. This is where we make use of it. Note that in finding antilogarithm, to know where to position your decimal point in the antilogarithm, you add 1 to the characteristic of that number you are asked to find the logarithm. Now, the number we're asked to find the logarithm here is 0.3416. The characteristic of this number is what?
Ma'am?
The characteristic of this number is what?
Is minus.
No, the first one.
Okay, 0.
0, good. So now, you add 1 to it. That is the constant thing. You add 1 to it. You add 1 to the characteristic. When you add 1 to the characteristic of 0, in this first example, 0 plus 1 gives us 1. Now, that 1 we get, whatever we get after adding 1 to the characteristic, tells us where our decimal point will be on the antilog we just checked under the table. Now, the antilog we just checked under this table is 2196, right?
Yes, ma'am.
Adding 1 to the characteristic of 0, which gives us 1, tells us that we are fixing the decimal point after the first digit. It says, and fix the decimal point on the antilog number 2196 to get 2.196. 2 points, that is the decimal point comes after the first digit, which is 2. So that's how we got 2.196. Do you understand?
No, ma'am.
Now, but you understand how we got to 2196?
Yes, ma'am.
Hello, madam. You have 5 minutes more. But I would suggest that after the exhaustion of this time, we can begin another class, if you don't mind.
I mind.
Okay, so just try to round up this in 5 minutes time.
Okay. Let me finish explaining this. Okay, after getting 2196, now the next thing to do is we want to fix our decimal point position. How to fix our decimal point is you add 1 to whatever characteristic you have. Now, that is when you have a positive characteristic. In the case where you have minus as your characteristic, something else applies. But in the case of a positive characteristic, in this example, for instance, we have 0 as our characteristic, which is a positive characteristic. Do you get it?
Yes, ma'am.
Now, what happens is that you add 1 to that characteristic. If the characteristic, for instance, for example, 1 is 4 points, you add 1 to it and you get 5. If you get 5, that means you are putting in decimal points. You just apply decimal points. Just put in decimal point after the 5th digit, given that you got 5. Now, in this case, we have our characteristic to be 0. 0.34160. Add 1 to that 0. That's the normal thing. Like maybe that's what you're trying to understand. Don't worry, that's just how it works. You just add 1 to the characteristic of 0, which gives us 0 plus 1 is equal to 1. Do you get that?
Yes, ma'am.
Having added 1 to the characteristic, which gave us 1, we are going to, this tells us that on that antilog we already got 2196 in this case. Our decimal point comes after the 1st digit because we have 1. Our decimal point comes after the 1st digit. Do you understand?
Yes, ma'am. So if we now
So we
have
have
two,
it
then
the
what if
first
we
digit,
have
which
two?
is 2. If you have 2 as your characteristic, Abby, or after
Yes.
adding 1, you have 2.
Yes, ma'am.
If after adding 1, you have 2, your decimal point comes after the 2nd digit. In this case, let's assume after adding 1, we have 2. Then our answer will be 21.96, coming after the 2nd digit, which is 21. But in this case, because we have 1, after adding 1, 0 plus 1, 1. So the decimal point comes after 2 because 2 is the 1st digit. So we have 2.196. Do you understand?
Yes, ma'am. Thank you, ma'am.
So I'll be stopping here for today. We'll continue next class.
Thank you, ma'am.
I should have continued, but I'm kind of tired. I had a busy weekend. Sorry.
Okay, no problem.